Welcome everyone to Hotel Q&A. We have the pleasure of having our good friend Hazel Weakly come talk to us about her experiences with observability. Welcome, Hazel.
Glad to be here. Very excited for this.
Yay. I guess let's start first things first, because I know we still have a bunch of Hotel novice users, like just getting into Hotel folks who join our end user working group. So from the perspective of somebody who's new to OpenTelemetry, can you share what that experience was like? What kind of landscape you were coming into? And I guess for starters, like drawing back on that experience, was the company at that point ready for observability? Like, did that what kickstarted the conversation into OpenTelemetry in the first place?
I would say, so I'm going to start off with my definition of observability because it's slightly different.
Okay.
The definition from control theory would be like, can you understand the state of the system from the inputs and the outputs? And Fred Herbert likes to talk about the definition from cognitive safety systems engineering. And that one is much more about the work required and the process required for a group of people to be able to understand everything and actually understand the system. And that's how they like discover and think about that. And mine is the process through which you develop the capability of asking meaningful questions and getting useful answers. And so it's a process because it's evolutionary. And the questions have to be meaningful to you, whatever that means. And the answers don't have to be correct, but they have to be useful. So when I look back at the company when we were starting to think about observability, and or rather like distributed tracing, it's really what are the questions that the company is starting to ask from the perspective of the engineers? And what are the questions that the company is asking from the perspective of the managers, and what is it asking from the perspective of the executives? And so from the engineers, at one of the companies that already had OpenTelemetry, they had it and they had instrumented things with it. But more from the perspective of, we know we need this, but they didn't necessarily have that motivation yet. They actually weren't asking the types of sophisticated questions that motivate people to add their own telemetry. And so consequently, they had a bunch of telemetry, and they had a huge amount of auto-instrumentation, and they had just the volume turned up to 11. And no one was actually really querying that information. And so what I was able to do was turn down that volume significantly. And then what I did was essentially say, you're not using this, and you're not asking any questions from your system. So when you do, don't turn the volume back up, like add that instrumentation in there with thought and intent. And that was an interesting hurdle to happen, because the way people would ask questions is they would ask these types of semi-sophisticated questions, asking them to understand the state of the system. They were asking them to solve a problem. And so consequently, they just wanted every bit of information ever, so that whenever they needed it, they could just like go through a giant stack of noise and find a needle.
Right.
And that's not really what OpenTelemetry is for, or like distributed tracing. It's for, can you understand the state of your system to the point that you only collect what you actually need? And that is, in of itself, a second layer of understanding the system. And they didn't have that second layer.
Right. So it sounded like they were instrumenting for the sake of instrumenting and just sort of throwing everything at the wall and hoping something would stick.
Yeah, that also sounds like a very, I came over from logs and I'm used to being able to search everything ever approach.
They also still had logs, which surprised basically nobody.
Of course. So in terms of like, how did you convince them to kind of tamp it down and direct it, make it more directed so that it could actually work for them?
So convincing them to tampen it down and turn the volume down was actually pretty easy. That came down to cost. They were about 300% over budget for the vendor. And so I said, I need to get you under budget. And so I actually, in the honeycomb pollinators, I have a very funny image from that time period where you see the ingestion at about like 200 to 300 million events per day. And I'm trying to tweak it and I get it down to about like 200 to 250, or like, 180 to 250. And that was with very, very aggressive sampling. And finally, I figured out a bunch of misconfigurations in the sampling information and dropped it to about like 3 to 5 million events per day.
Awesome.
And so once I had solved that, they had concerns about, oh, what if I can't find something? And I said, well, do you need to ask that question? And then we were able to actually start the useful dialogue of, now that you have a question you need to ask, go and build what you need in order to get that answer. And then that's really that sort of feedback loop that you kind of need with observability, which whether or not you need that feedback loop end to end is a different question, but that is currently what OpenTelemetry requires.
I think that's really great because being able to know what questions to ask makes it for a much more meaningful experience. And so, in your words, not searching for that needle in the haystack. Now, I want to go back to sampling for a second. Do sampling?
So sampling was, we did the sampling through two methods. We had the OpenTelemetry collector, and actually no, at this company, we only had the Honeycomb refinery set up. And so we had that set up. At other companies, we've had the OpenTelemetry collector set up, and I've used that. My preference is actually to use both, regardless of whether or not you're using Honeycomb. And the reason for that is because the OpenTelemetry collector doesn't have the best tail sampling configuration. And the OpenTelemetry collector has the most open source, agnostic sort of configuration setup. So you can set things to multiple sources and multiple sinks. So that is actually really useful. So I like to use that one, and then aggregate everything, send it to refinery, and then do useful tail sampling. But running two pieces of infrastructure is kind of complicated for a lot of people. But that can be a huge hurdle of adoption. So at my current company, they use Datadog. And one of the challenges there is they're not at the point where they can ask sophisticated questions of their infrastructure. And they're really still more at the point of, is it on? And so the question there is, well, even if I set things up for success by switching us to the OpenTelemetry instrumentation tooling, and then still send it to the same place, we now need to run the collector in multiple places, or run a collector and refinery, just in order to do the same thing that they already do with their built-in tooling. So that can be a bit of a lift, because rather than saying install a library, it's install a library and have 5 things also.
All right. Now, going back to the first organization where you're, where they were sending way too much data, after you convinced them to kind of chill, do more directed instrumentation, what was the next sort of hurdle that you experienced?
The next hurdle there was that the way that company structure work was very much they over-platformed things, which was unusual. But they had developer productivity teams, and they didn't really have a platform team, but they had engineers that didn't do work. So the engineers didn't do infrastructure stuff, they just wrote code. And they would have a bunch of people working on build tooling and build other stuff like that. And so the question was, in the way that they do work, in order to adopt OpenTelemetry successfully, you would need to essentially build libraries for things, or write stuff into the code in a way that engineers weren't necessarily writing their own instrumentation. And that requires working at a level of abstraction that OpenTelemetry makes really, really difficult. So you can't propagate certain types of information down to child spans very easily, or really at all. Setting up baggage is still very difficult. Working with context can be really tricky. If somebody uses an async function, then you might drop that and have to reconnect it somehow. And if the lifetimes aren't already set up nicely, people can even add their own instrumentation, and then it'll get dropped from something because they don't actually understand the full context of where it is. They're just writing code and they add something. But in OpenTelemetry, you have to understand the call stack, not just the functionality, and those aren't always the same.
Interesting. So how do you get over that hurdle?
So at that company, I was never able to fully get over that hurdle. I just made it better.
Ah,
And
okay.
one of the ways that I made it better was essentially trawling through all of the spans manually and looking for errors. And when I found errors, I would like trace it down to the source code, and I would do that. And so I ran into like a bunch of very small things of like propagating source code information wasn't correct. So it was propagating the information of like the helper functions rather than the actual call sites. So I had to fix that. And then I had to fix like 5 other small things. And even when I did that, I found that there are a bunch of places where asynchronous contexts weren't being propagated. So functions were just being lost. Or functions were calling tracing and that was being disconnected from the actual whatever. Or sometimes things had to end before they started or start before they ended. And that got confusing because the language that they were using makes it very easy to write code in that logic. And it actually is more correct to do it that way. But OpenTelemetry in its design is very much a synchronous call stack, tree-shaped code base, which is really, really ergonomic for a language like Java. It's not necessarily ergonomic for languages that aren't like that. So like React is a really common example because it's a runtime that's asynchronous. And it's really difficult to write code in React that does that nicely. Haskell is a good one. Closure is a good example of one that doesn't work very well. Rust does work, but for a very interesting reason. And that is because the Rust language cares about lifetimes. And so you think about the lifetime of your functions. And so you always know where those are. And those end up being the natural tracing point for a call stack based tracing library. But in terms of what we were able to do and how I was fixing it, it was really mostly whack-a-mole and doing some weird and clever things to hack into the language runtime in order to make things fit the semantic model differences between OpenTelemetry and how the language thinks about calling code.
So were you like a one-woman show doing all of this?
So the other person on this was off on parental leave. So for the duration that I was doing this, I was actually one person show.
That is mad impressive. Did you want to like pull your hair out some days?
It was tricky. A lot of it was that one of the benefits of using OpenTelemetry is that you get like this intuitive sense of what the code is doing at runtime if you play with it enough. So you have to sit there and kind of like doodle with it and like look things up and like ask questions and get answers, and like you have to have that dialogue running. And I knew how to do that, and no one else at the company was doing that except for like 1 or 2 people.
Wow.
And so you had like a very small select power users group of people, and then you had everyone else who may not have even like used OpenTelemetry at all, or even used like a vendor in any way whatsoever. And so I would get an intuitive sense of what was broken or what was wrong or something. And I would say, hey, like this is an issue. And then people wouldn't necessarily believe me.
Oh, interesting. So how do you end up convincing them that it is an issue? Or could you convince them, I guess, is the question.
So when I was able to convince certain people that things were issues. And one of the ways that I did that was essentially like predicting things, and then my predictions would turn out to be correct. And then I would give a solution to the prediction, and then the solution would work. So like one was the database was very, very spiky. And I mentioned that this was going to cause like some sort of outages. And one of the reasons that the database was spiky was because we had like basically the disk was slow on the database. And so we sped up the disk on the database quite a bit. And when that happened, like the spikes leveled out. The usage was still very spiky in general, but the spikes weren't going high enough to lock things down. And the small things like that added up over time, and people started to believe me a lot more when it came to certain issues. But other ones that were more fundamental in the architecture, I never actually got around to being able to convince people of that. And I actually ended up leaving that company mainly due to that.
Interesting. So did you, by the time you left, did you find there was at least like they were getting more out of their observability at that point, like because of your efforts? Like, did you at least see some positive results because of that?
Yeah, I did. So there was a lot better understanding of where they were with the observability. People had more of an understanding of how to use it. I had like fixed a couple of things so that it was more useful. But like they had a lot of it, but some things were wrong. Like if the error stack was there, the error stack died at the wrong spot. So it wouldn't actually tell you where the error happened. It would tell you where you defined the OpenTelemetry, like the tracing helper, which is pointless. So I fixed that, and then all of a sudden the errors were correct again, and people were happy about that. Then they would actually use it. So I had fixed a bunch of things, and I had reduced the usage from like 200 to 300 events per day, or even 350 million events per day to like 3. And when that happened, then people could continue to add OpenTelemetry and add instrumentation everywhere without running into the risk that they were going to blow their budget even more than they already were. And that allows people to continue to add more instrumentation.
So then I guess it seems like there wasn't an issue per se as far as like getting people to add the instrumentation at that point, because they were obviously they had already over instrumented the system previously. So now you put them in a position.
It was interesting. They had over instrumented it, but only via auto instrumentation. So there was very little manual stuff done. And the manual stuff that was done was often done in a way that made the questions you can ask relatively useless. So like one example was there's like at the top of a request, halfway down is when in the life cycle of the call stack is when they would actually get the user ID associated with it because of how the database calls worked. But that user ID was never propagated to the top, so it was actually impossible to figure out like how many pages a user was visiting, or like per session, like these types of questions, or whether or not a user like saw the same thing over and over. Because the question we wanted to ask was how effective would database caching be? Like, would it be effective to put Redis there somewhere and like query that and have a 60-second something TTL? We had no idea because we couldn't actually ask that question. All the information was there, but not actually in a way that made anything possible to look for.
Right.
Because you couldn't look halfway down the span in order to get this span correlated with this one. So that tree, you can only ask for things on the same level. You couldn't like go from the level and down and like filter that way. And so they needed to fix that, but no one necessarily knew how to. And no one necessarily knew that they wanted to because they weren't asking that type of question. So I brought that up, and then people started to get more of a sense of, oh, here's kind of where we put the information in a way that's visible. And to this day, I still don't have like a really good way to like explain to people how to think about that, other than you do kind of need to display the system and get an understanding of where the data needs to be in order to be useful for asking questions.
Right. Yeah, that makes a lot of sense. So yeah, that's so interesting. Like, I find this such an interesting sort of, I don't want to, well, I guess use case of sorts, scenario, if you will. Because there oftentimes we hear the stories of people just struggling with bringing OpenTelemetry into the organization, and then starting to instrument. And this feels like it was like one giant anti-pattern of one giant OpenTelemetry anti-pattern, which I think it's a very important thing to be able to discuss, because like all tools, OpenTelemetry can be grossly misused, and then you end up with scenarios like this where you're instrumenting but you're not getting anything out of it.
It was really interesting to see how this happened, because a lot of what happened is due to how the company works and how it thought about working. So it was very anarchic, in the sense that engineers are very, very self-directed, and they would do things. And so the company had a huge cultural issue of things would get 80% done, or things would get maybe like 90% done, and then they would just drop off if someone like got sidetracked and had to do something else. And no one else would pick it up, and no one would like sit there and make sure that things got like fully finished. And so that essentially happened, where we had one employee set up the main amount of instrumentation, and then one or two people added like some things to it, and one or two people added some things to it. But no one did like that last 20%, of
Right.
actually tuning things down. They
Right.
just, they turned everything on, they turned it all up, they added a bunch of things, and they added the instrumentation, and then no one actually necessarily used it. So,
Right.
for example, the database instrumentation library was something they had to write because they used Haskell as a language. And what that meant was they had, for each database query, they had 4 different spans. They would make a span from the start of the query, the start of a transaction, an end of a transaction, and end of a query. And so then you had the span for the query itself. So every single database call cost at least 4 to 5 spans to appear.
Oh, wow.
And there's no way to configure that or turn that down or coalesce things or anything like that. And so what happened was that worked great. And then anytime you had like a n+1 pattern just appear accidentally in the database, you would get millions of events. Just like millions of spans all over the place. And then they were like, oh, well, what if we used span events instead? And most vendors like either charge per ingestion or they charge for and so that actually doesn't shift the cost anywhere. It sometimes makes the user interface slightly better, but it doesn't shift the cost. Which is one of the reasons why people say like have one wide event where you put things in there and then have timestamps and be free to use that. But they were using the SDK essentially as the timestamp functionality. They would create an event anytime at any time mark that something happened. Or they would create a span anytime something happened, and that pervaded all the way down to the auto-instrumentation. And so that was tricky. That was part of that 80% of now we have instrumentation in the database. But no one actually said, well, it turns out literally every other database SDK lets you turn 90% of the auto-instrumentation off, and for a good reason. Same for instrumenting the HTTP server, the web server. You had the web server, and then you had the web framework, and both of them had almost identical levels of instrumentation. So depending on which endpoint handler was in place, you either got one top level or the other top level or both. And so you had massive amounts of duplications of the amount of spans that you might not need.
Oh, interesting.
And it turns out it's largely because there wasn't really an ergonomic way to say, add this to a span if it exists. Otherwise, create your own span and do that. That pattern is really necessary for libraries, and it's not actually really relevant in the SDK. It's not really mentioned anywhere, and it's not really possible for a lot of languages to do.
Right, right. Yeah, that is an interesting problem to have. So now, when you were helping this organization with OpenTelemetry, how well versed were you in OpenTelemetry at the time?
So I was knowledgeable of it, and I had thought about it, and I had done some things with that. And there had been a previous company where I had really played with OpenTelemetry and React. And I had set up some very interesting and overly clever TypeScript helpers that made things really easy for people. And I had familiarity there. But this company is where I had to really dig into the refinery, into configuration, into operationalizing it, into controlling the cost and understanding it from that sort of perspective of the operator rather than the end user. And so that was an interesting change perspective. And I ended up reading pretty much the entire RFC for everything, most of the SDK code, most of a whole bunch of other things. And so I dug really, really deeply into it. And to this day, still don't necessarily understand baggage. I understand it, but it's kind of not well implemented.
Yeah, you were mentioning earlier that it's funny because I was reading up on baggage today, and you were mentioning earlier that baggage is still kind of wonky to work with. What is it specifically that what were some of the challenges in working with baggage that you experienced? Because this would definitely be good feedback for the hotel folks, the maintainers, and what.
I would say it comes down to baggage is a really generic tool that ends up being used for 5 different things. And they mostly come up when you want to stitch together multiple services, or when you want to write a library or do something like that, or write a platform for people so that they can instrument things very easily and not have to worry about certain underlying implementation details. You can also use baggage to paper over the API of a lot of things and do what you want to, even if you shouldn't necessarily do that. So, like for example, baggage or just context propagation in general is more or less the only way you can have a directed acyclic graph. Otherwise, you only really have like a linear call stack. And you have like some ability to form links, but not like even that is pretty unergonomic because you need to know where you're linking to and where or what you're linking from. But baggage will let you like put things in headers so that you have cross-service tracing, the actual distributed part. Baggage is also the thing that you need if you want to propagate information down to propagate information up a chain. And it's also what you need if you want to write some sort of span processor as a way to work around issues. So if you want to have like something added to multiple spans down, then the only way to do that really, as far as I can tell, is to write a span processor and use this baggage to pull that information out. So you would add something to the baggage, and then as the span processor is reading through all the spans, it'll reconstruct that whole tree and figure everything out and then add that in there. So you more or less rewrite refinery in your code base, or rewrite the OpenTelemetry cluster in your code base in order to use baggage in order to add certain features that aren't in the SDK yet.
Oh, interesting. Did you find that with other aspects of OpenTelemetry as well that were kind of limiting for you when you were working with it, when you were digging deep?
It was. I think the main thing that was limiting outside of that aspect was that it's really hard to make adding instrumentation that's manual ergonomic. Like, it's just difficult. And a lot of that comes down to OpenTelemetry really wants you to like have written the code right there. And so you need to kind of know how to do that. And it's very hard to wrap the libraries themselves without adding like that extra layer of interaction that makes things hard. So unless your language has a very expressive macro system and you can use that ergonomically, it's difficult to do that. And so like Ruby gets away with it because it can monkey patch itself, and that's how you get that one layer of interaction removed. Rust has an expressive macro system, so you can get around that. Languages like TypeScript don't. And so in TypeScript, like what you really want is something like a decorator, but you can't get that. And the other issue that I really ran into ergonomically with OpenTelemetry would have been based around asynchronous work. So asynchronous work was probably one of the larger banes of my existence. And the reason for that is there's multiple different ways you can write and express asynchronous work, and there is one way that OpenTelemetry works well with, and that would be if the parent function calls a child function asynchronously, passes a context into it, and then waits and outlives the child function, and then ends its own span. And so you have like asynchronous work, but it actually exists fully inside the lifetime of the parent span. Anything other than that use case gets really weird.
What about span links? Aren't they supposed to kind of alleviate that though?
The span links do work, but you have to know how to use them. And so the parent still has to call the child, and then the child has to have the parent ID in order to link to that. Or I think vice versa. I don't know if you can do the other way around. But essentially, I couldn't write a function generically that was unaware that it was being called from the parent, and then had to link up to the parent. And so that was tricky because a lot of languages, you want to write like a library or something, and the library can be very agnostic. So I don't necessarily want to say this function is called from a tracing context all the time. I want to say this function is called asynchronously in this context that's relevant to the application domain. And sometimes that's in a tracing context, and in which case it's being called asynchronously. But sometimes it's called synchronously, and sometimes it's called in a different context altogether. And I can't express that with OpenTelemetry very easily, if really at all. So linking was what you do for fork join sort of async patterns, but you can't do that like very easily. It's very unergonomic in a lot of languages.
Got it. And speaking of languages, like what languages were part of that landscape in that organization?
So this organization had TypeScript and Haskell as its main languages. But I've also done OpenTelemetry with, I've done it with React, done it with TypeScript, done it with Haskell, done it with a little bit of Golang, and Python.
Which one was the least annoying to implement?
Least annoying to instrument would be probably Python, because so many other people use Python, and Python is used in more of a server-side context, and so OpenTelemetry is often used there. That was actually more ergonomic. Python also has like more like decorators and meta programming and things like that to make it easier to work with.
Yeah.
React is interesting because it's both a front end and a back end like thing, and so a lot of things that you can do with it may have to run both in a browser context and a server context. And OpenTelemetry works really well server side and very not great on the client side. And so dealing with all of those issues can be really tricky, and it makes writing an API that works well on both really, really hard. So like on the client side, you want to send as little data as possible. On the server side, you want to send as much data as possible to the collector so the collector can filter it. And so you have conflicting needs there. You also have the issue of like, how do I actually send data to the collector on the client side, which is kind of solved, but not really. And you end up like writing an API endpoint that just forwards things to a collector so that you can transparently authenticate or not authenticate in a way that like actually works, and you can start to try and filter out noise from actual signal. Like, is someone calling the endpoint, or are they just like hitting it because of DDoS or something?
Was React then the most annoying one to instrument, or was there another language that you've worked with that was even more annoying?
Haskell was the most annoying one to instrument.
How big is like the OTel support around Haskell?
The OpenTelemetry support for Haskell is actually pretty decent, which is really funny because Haskell has a bigger usage community-wise than Rust does for OpenTelemetry. Yeah. And so Haskell is an ergonomic language. It's very expressive. It's very interesting. But the runtime of Haskell is absolutely absurd and makes OpenTelemetry extremely difficult. So Haskell is a fully lazy language, which means that if you write the code, you don't have any control over the lifetime of when the code is executed or actually evaluated, or how deeply it's evaluated. And OpenTelemetry really, really wants you to explicitly call things, have it start then, and have that happen at certain like points. And so in Haskell, the laziness makes it interesting because you end up peppering the laziness with a bunch of strict functions, which are the tracing stuff. And so that can mess with your memory usage, it can mess with your performance characteristics, it can mess with a couple other things, and it's very, very difficult in language to have something be quote transparent, which you want the tracing to be transparent, otherwise the tracing is really tricky and it breaks a bunch of other things. And so making it transparent actually requires the use of unstable primitives exposed by the internal implementation details of the compiler and the runtime.
Interesting. I feel like I learned something new today. I want to go back to another point that you had made earlier on, and hopefully I understood it correctly. I think you made a point saying that generally organizations do tend to like create libraries around OpenTelemetry. Did I understand you correctly?
Yeah. And it's not necessarily that organizations tend to do that. It's that is one of the best ways to multiply efforts when you have like a platform team, when you're thinking of things in a platform engineering manner. So in general, if you have like something people need to care about, like testing or instrumentation or runtime performance or some aspect of the code that isn't necessarily functionality, getting everyone to care about that equally is really hard. getting everyone to have the same level of knowledge is really hard. In fact, it's kind of not even so much as impossible, but I think it's a goal people try too hard to hit. And consequently, it ends up being very, very useful from a organization perspective to accelerate your developers by having like libraries built around things or like platforms built around things. So you have like maybe a starter template, and then your instrumentation's just dealt with, and your CI/CD is just dealt with, and a whole bunch of other things are dealt with, and then you can use it, but the structure is already set up.
Yeah.
So setting up the structure, giving people capabilities for handling things, taking care of like distributed tracing so that cross-service instrumentation just works out of the box. All of those things would be things that I would want to deal with from a platform team perspective of making telemetry easier to do.
Yeah, that makes a lot of
sense. And they are all really hard.
So was there at this previous organization, even other even subsequent organizations, is that something that it's one thing to I think have the aspiration to like abstract that stuff from folks to, you know, make sure that they're at the same level when it comes to instrumenting. It's another to like be able to achieve that goal. Do you feel that in any of the organizations where you worked that has been actually achieved with these kinds of libraries?
I've been able to get things to a point where it was achievable. Whether or not I actually achieved it is a different question. But so what I mean by that is I was able to figure out ways to like wrap and abstract away the vast majority of the setup for OpenTelemetry for like TypeScript or Haskell. And I was able to write wrappers around functions in a way that the wrappers were transparent, so we could have like a bunch of environment variables populated in and a bunch of like sort of setup for things dealt with in a way that people just needed to set up the application in a certain way, and then you got like the very base skeleton of the tracer and all those things actually just ready to go.
Right.
And they could like get the, you know, with active span sort of function and have like a more limited and understandable API where you didn't need to pass in certain types of context manually. They've been able to do that for both. And I've even been able to do that in a way that works isometrically in JavaScript or like TypeScript. And what that means is you can have the same code running in the server and the browser and it works. And that involved a mild amount of crimes. It involved a lot of crimes. It involves a lot of crimes. You abused how node modules cached a bunch of things, and then you checked for certain globals, and then you ran certain stable code here and there, and then if you import everything in the right order in the right place, and then you rely on trace shaking, then your bundle on the server can be different than your bundle on the client, and you can end up splitting that out in a way that doesn't break the global singleton pattern of observability of the OpenTelemetry stuff.
Now,
which is not trivial and also not explained anywhere.
Switching gears a bit to more managing the infrastructure side of OpenTelemetry, how was that experience for you in contrast to having to, I guess, to previous roles of being more, I guess holistically focused or having to like clean up the OTel mess? How is that in contrast?
So running OpenTelemetry is interesting because like you have the OpenTelemetry collector to run, and the collector, like then you have to set it up, and if you go outside of essentially any of the very small documentation examples, you end up having to read the RFCs for things, or you end up having to read the technical like design documents, and they are not obtuse, but they're understandable by like a select amount of people. Right, and right. You have to really dig in to understand that. So like even for the tail sampling configuration of the OpenTelemetry collector, like that entire document of how to do it is the most difficult thing I've ever seen. It has like 6 different layers of things, and each one has its own like entire language and specification setup, and it's wild. the honeycomb refinery is much better in that regard, but running a refinery in production is a janky mess in a lot of ways. And that largely comes down to refinery is really a tool that they built for themselves, and then they made it available to other people. And so it's, here's refinery. If you know how it works, great, you just run it. But otherwise, you can run a refinery successfully if you're an organization with high performance CI/CD, the ability to instrument things and look at them, and you have that ability to like dial things down very rapidly. Otherwise, refinery is not going to work super well for you. And so the organization that I ran a refinery in split the difference. They had some amount of rapid CI/CD and some amount of that, and I was able to look into logs and stuff like that and get some things dialed down. But the usage pattern of refinery, due to how broken the OpenTelemetry stuff was, we ran into essentially every error case and edge case of it. So, for example, one of the edge cases that we had was many spans were not like, a minute or two long. Many spans were hours long, or even days. And we had some spans that were multiple weeks in length. And we also had some spans that had over 3 to 5 million events in them. And what that ended up being was you would have something that would go, a start task. And then so that starts a span. And so this would be like an asynchronous job. And so the asynchronous job would, for every single user in the database, do a whole bunch of validation stuff. And so that would be about like 1,000 spans per user times 500,000 users, or 20,000 spans per user times 40,000 users, and so like it's ridiculous. And or like for every single item in the database, check its consistency in one span. So that would take like 20 hours, and that would break every possible configuration of refinery. You just can't have a span that's not broken, and also have refineries store 50 million things in memory. So I got things improved, and but ultimately I ended up saying this entire way we do OpenTelemetry in like this with an asynchronous job is actually close enough to streaming services that it doesn't work that way. And so the way to do the streaming services is to do it the way Honeycomb does, which is you have like, you just send a snapshot of a span every like minute or so, and you roll up things in the code. But that requires you to have written your code in a way that you can roll things up and then send it every minute. So you need to completely rewrite how you do most of your task handling to have some sort of like task handling manager that sits there and can collect a bunch of things and every minute do that and start a new span. And that is not really possible the way most people write asynchronous tasks. And fixing that is really tricky, because there's not really a way to fix that without actually just rewriting the code. It requires you to really just start a million different tasks, and each task is linked together casually by like span information, and then the collector sort of like does some things in there, or maybe your span processor can roll that up, but otherwise you can't actually do that. Now, you should do your tasks in that manner anyway, because then it allows you to have a write-ahead log, and then you can ensure task consistency if the long event gets dropped or interrupted in the middle. So you should do that anyway, because that's how you do it if you understand distributed systems. But you run into this thing in OpenTelemetry of it was written by systems-minded people, and so a lot of the design decisions that they make sense if you know how to write a strong distributed system. Like, of course you use a write-ahead log, of course you journal things, of course like you wouldn't just spawn an event for like, or spawn one task somewhere for like 20 hours. Who does that? Everyone. Everyone does that until they know better.
That's a really good point. We've got about 6 minutes left, but before we wrap up, I would like to talk briefly about some of your experience in trying to make the case for OpenTelemetry to executives, because that can be challenging.
Yeah. So OpenTelemetry. making there's two sides of it. There's making the case for any sort of monitoring or observability in general, and there's making the case for OpenTelemetry specifically. Potential and so the second case usually happens when you have some pre-existing stuff and you're arguing we should not use the pre-existing stuff when we should use this other thing instead. And so what you're arguing for there is a migration, two migrations, a technical migration and a social migration. And those are very tricky. And so you want those both migrations to happen. And so you need to be able to essentially show that the time and effort saved via this migration will pay for itself in about 4 months. And if you can't show that it will pay for itself in about 4 months, then you probably shouldn't actually do it. And you should figure out how to make it pay for itself in 4 months and then do it. Otherwise, you'll end up with a migration that takes like a year or something, and it has no perceivable difference in benefit, and then people are not going to be sold on it. People need to actually tangibly feel the benefit, or the migration is going to fail on the social aspect, even if you succeeded technically. For convincing organizations that you want to get like any sort of monitoring in general, that relies on being able to convince people that the lifecycle needs to encompass more of the lifecycle, and the easiest way to do that is, in my opinion, you tie the code lifecycle to the business value delivery lifecycle. So what can happen in organizations is you have like the developer lifecycle, which is over here, and it's I write code, I commit code, I merge code, end. And you have the business lifecycle, which is we could we do some market research, or we get like some sales research, and then we design a product, and we get the product features, and then that product feature is implemented, and then we see what the feedback is. And at no point do those two overlap or cross. So that leads to people just like product owners handing features over to developers, and developers writing code and just handing it off to production. And instead of playing frisbee, you need to merge those. And when those get merged, then essentially developers have to care about things all the way to the point where it delivers value to the customer, which is actually what every executive already wants to have happen. The state they have with things separated is what they think is like, has to be that way. And the second you say it's possible and even desirable to get developers to care about like the actual outcomes for the customers, get them talking to salespeople and get them talking to like product people, and that will not only improve things for the product, improve things for the end user, but it'll actually improve the productivity of the developers and their experience and their ability to do this. That usually sells executives on you need this. The next trick after that is once they have you need this, if they just look for like observability, they're going to get one of like 3 or 4 different vendors, and you're probably going to end up with an expensive vendor, and you need to pick a vendor based on what the business needs and not necessarily what you like the best. Like for example, at my current company, we have FedRAMP monitoring compliance requirements. We have it for only one environment, but that pervades more than one code base. And so because of that, no one in the company can use anything that isn't FedRAMP compliant, which significantly limits the amount of vendors we can have to basically one. And I don't necessarily want to use that vendor necessarily, but I have no plans to migrate off of it. If I were to migrate off of it, it would be in a very interesting manner. What I would do is I would split the environment into 2 environments and have them be identical. One FedRAMP certified, one not FedRAMP certified, and then essentially we would have a FedRAMP program, but that would be like a separate sales funnel. And anyone who actually needs it can have that, because FedRAMP is valuable in 2 aspects for the business. One is that it gets them certain customers, and one is that it gets them certain conversations. And for the conversations, those people may not be on FedRAMP, but they may want it eventually. But it means that I can run the same code base in both locations and use a different vendor in the one that isn't FedRAMP and a FedRAMP verified vendor in that one. But that whole migration for the current company would be like 2 years of work. So are we going to do that? Who knows? Maybe. But there's a lot of other questions to ask first and a lot more that we need to do before we can even get to that point.
Yeah, speaking as a vendor, we've had a lot of conversations about FedRAMP certification, and being that not 100% of our employees are in the US, we'd have to do exactly what you describe. And we tried to do that before for HIPAA, and it created kind of a weak experience for some customers. So yeah, it's a tricky problem.
Interesting.
Yeah, like the divide into two environments, push to both environments. Eventually, we figured out that it was hurting our whole development velocity to push to those two different environments. And even though we thought it would be very straightforward.
Yeah. Because, the environments aren't identical. And if you turn one thing off in one environment and keep it on in a different environment, you're going to get like a completely different experience. And so what if you have an outage in one versus the other? Yeah, there's no way it doesn't hurt development velocity. The question is whether it doesn't hurt development velocity more than the benefit from having a different vendor for something else does. So like if having one vendor would be extremely beneficial, and that benefit is more than the harm you get from harming developer velocity by splitting your production environments, then maybe it makes sense to do that. But realistically, it probably doesn't, because having homogenized tooling that you can build on top of for yourself often ends up having a higher reward than having like a, quote, technically superior vendor. But you have to invest in that yourself.
Exactly. Yeah. And in the case of the HIPAA stuff, it didn't, because we were able to bring support into HIPAA, and there were only like 4 customers on that sort of private honeycomb instance that had more support for HIPAA, greater support for security. And they were large customers, but it was like, we can't the fact that they were large customers meant that they made requests, and that eventually warped the two environments to be significantly different.
In my experience, one of the most interesting things about HIPAA is that any sort of regulatory environment, there's one regulatory environment, and then there's like FedRAMP. And the overlap between people that need any regulatory environment and people that need or really want FedRAMP is basically a circle.
Yeah.
So if you're going to go like, oh, we're going to have like a HIPAA environment, or we're going to have a FIPS environment, or we're going to have like, a SOC 2, like it used to be SOC 2 anyway, whatever. But if you have like one of those, you probably would actually get as much benefit, if not more, from going straight to FedRAMP, even though it's like 3 times as expensive to do that, at the least. And the ongoing maintenance burden of that is ridiculous. But it gets you on the other customers who need like HIPAA plus FedRAMP or FIPS plus FedRAMP. And that is a really interesting like business thing that's non-obvious. So any type of regulatory environment completely changes the game for OpenTelemetry, what you can do with it, how it works, your vendors in general, and even like your hiring practices. And it's really weird that you can't really half-ass it. Like you can't just get HIPAA, you really should probably go all the way to FedRAMP. Just because of who the market is that needs one or both.
Yeah, I totally agree with you based on like our experience with that HIPAA server, because it turned out there were companies camped on it that just had, who went for that offering, that just had a desire for like more privacy, stricter controls because of how their company culture and their data worked, without actually having the need for the federal regulation. And I think you're right that it makes it easier to sell. I think probably we wouldn't end up going in that direction again unless we managed to partner with somebody who was actively like bringing in FedRAMP customers, like some agency that worked with the government or whatever, like would have to be. But I wish we had known that at the start, and we didn't.
One thing that would be interesting there would be to have OpenTelemetry have some sort of like agency that, and that agency gets FedRAMP compliance. And then what you can do with that is you can have that agency essentially facilitate the onboarding of OpenTelemetry vendors or just other observability vendors into the space. And you can use that to sort of start bridging the gap and getting people more capabilities and sharing that like FedRAMP specific architecture concerns in a way that spreads the compliance load amongst multiple companies. And if you could do that.
Oh, sorry. I was very excited by that idea. That makes a ton of sense. we could maybe make it work through the project. And I would say for us as a small vendor, that really is a problem, that if we are not allowed to have our engineers who are in other countries touch the system, we may only have one engineer working in a particular area. And so we have to hire a second person in the US, which is undoable.
There are certain ways to make that easier. And you would need to like talk to someone who's experienced in FedRAMP to like negotiate that. But having like 100% US citizenship is not actually a hard requirement. It gets nuanced and it gets tricky.
Oh, interesting. We'll file that
Well,
for
I
later.
think we have to leave it at that. 'cause
Sorry, we
are
got into a
still
funny
over
side discussion.
Thank you again, Hazel, for sharing your insights. This has been really cool. I don't think we get to talk to too many people who have had like such advanced use cases for OpenTelemetry, and being able to share that with the community is really good, because I think a lot of us get, you know, we do like those intro tutorials. We're like, hey, that's pretty easy, and then you get into like the guts of it, and then that's when you start getting into some of those gnarly use cases that really stood out.
Yeah.
So definitely
The guts of it can be really tricky, and like
yeah, definitely. So definitely appreciate that feedback and viewpoint. And you will be back for OTel in practice, I believe, on September 14th. Looking forward to that. Do you know what topic you'll be discussing?
No idea. I'm gonna figure it out, but it's gonna be a lot of fun.
Awesome. Really looking forward to that. Thank you again, as always. Super awesome insights. Yeah, and we will hopefully see everyone for OTel in practice with Hazel on September 14th.